Okay, we're on page 279. And there's no your turn questions on here, but there is a lot to learn. So I suggest you watch this video closely with me as we go through it. Maybe take some notes. And just in general, pay real good attention. Generating equivalent expressions, parts of an algebraic expression. There's a bunch of different vocabulary terms here we need to cover. There's terms. Terms are the parts of an expression that are separated by add or subtract signs. So all of these things are termed. 12 is a term, 3y squared is a term, 4x is a term, 2y squared is a term, and 4 is a term. And let's switch colors and talk about what coefficients are. Coefficients are the numbers that are multiplied by at least one variable. 12 is not multiplied by a variable, therefore it's not a coefficient, but 3 is multiplied by y, 4 is multiplied by x, 2 is multiplied by y. So there's 3 coefficients there. The difference between a coefficient and a term is that a term is just everything grouped together like 3y and squared, and a coefficient is just the number that goes with a variable. So if there's a number right before a variable, it has a name, it's called a coefficient. All right, like terms are when the terms are terms with the same variables raised to the same power. So for example, do you see this y squared right here? And this y squared right here? Since they're both y squared or y to the second power, that means those are like terms. There is no 4x. If there's not another variable with an x, let's pretend that there was a 3x here. If there was a 3x at the end, 3x and 4x would be like terms because they're the same variable to the same power. And then the whole numbers are like terms also, 12 and 4. Since they're just whole numbers, since they don't have any variables, those are called like terms. All right, let's move on. When an expression contains like terms, you can use properties to combine the like terms and write an equivalent expression. So that's this next skill. It's called combine like terms. The next 3 problems here, the book is going to show you one way, and I'm not going to disagree with the book, but I'm going to show you what I think might be a little bit simpler way. Okay, so let's say the directions were combine like terms and they give us 6x squared minus 4x squared. I bet your instincts would figure out what to do. Since this is an x squared and this is an x squared, what we can do is we can do the operation with the numbers 6 minus 4. 6 minus 4 is 2, and the variable is x squared. The answer to this question is 2x squared. So when it says write an equivalent expression, if you were to be given this 6x squared minus 4x squared, you would simply solve by writing that's equal to 2x squared. The way the book shows you to do it, slightly complicated. They're saying to use the distributive property, subtract inside the parentheses, and when we do that, I did that. 6 minus 4 is 2, and then 2 times x squared is 2x squared. I just think that they're this right here is what I think is the best part of their answer. I think this is fairly complicated. Let's check out the next one. The next one has us to use the distributive property to start. Now, what do I mean by that? You can't combine right now anything without getting rid of those parentheses first. So what I'm going to do here is I'm going to start with 3a plus, and off to the side here I need to do 2 parentheses b plus 5a. We've talked about this a couple times. The distributive property tells you to take the number outside the parentheses and multiply by everything inside the parentheses. So 2 times b right here is 2b, and 2 times 5a is 10a, and then I add this. Now I'm going to take these numbers right here, and I'm going to put them up next to 3a plus 2b plus 10a. So what I did here is I did 2 times b, that's 2b, and I did 2 times 5a, that's 10a. I forgot the a, 10a. So now I can combine the like terms. I couldn't do that before, but now that I've used the distributive property, I can combine the like terms. And what are the like terms? Well, I've got an a, b, and an a. The a's are like terms. So I'm going to go out of order. I'm going to do 3 plus 10. That's 13, a. And then I've got a 2b. There are no like terms there are no other b's. So I'm just going to add 2b. And that's the answer. It's 13a plus 2b. 13a, right here, 13a plus 2b, that's the answer. Okay, one more. This one might be honestly kind of the easiest. Well, it's probably not the easiest one, but it's pretty easy. Check this out. And the book actually does a good job of explaining this one. It's y plus 11x plus 7y minus 7x. So we need to start with what the like terms are. We've got a y and we've got 7y's. Well, 1y, and I know there's no 1 there, but we can pretend there is. 1y plus 7y's is how many? It's 8y's. And then that's going to get, see this added here? Actually, that it's going to be this, whatever. We've got an 11x. That's going to get added to, by the way. We've got an 11x minus a 7y. Pay attention to the fact that some kids would want to do 11x plus 7x, but the x's here get combined with the x's. But see this sign right here? That sign tells you to subtract. So I'm going to do 11x minus 7x. 11x minus 7x is 4x. So it's 8y plus 4x. Let's see what how the book shows you to do this. What they want you to do here is to change the order. They want to use what's called the commutative property to change the order. And so what that means is to take, we've got y plus 7x. What we're going to do is instead we're going to rewrite it as y plus 7y and do 8 and get 8y. And then we're going to do 11x minus 7x and get 4x. So this right here is 8y and this right here is 4x. 8y plus 4x. And you can't add the and the 4 because they're not like terms. They have to both be y's or both be x's. So it's just 8y plus 4x. All right, once again, I know that this is it's new and it's different and it's possibly really challenging you. And our goal here is that we're just introducing some pre-algebra to you, not that we're stressing you out and not that we're at mastery yet. But we are now done with page 279. Good job. You can go on and try some problems on page 280.